Good evening, my two viewers. Thank you for coming on. I'm just gonna wait a couple minutes until 7 o'clock. Let's see, what have I got here? I hope your day has been good. Um, there's. I hope everything is good in your world. Hmm. Hey, John, great to have you. Yeah, I actually remembered to send out the invite over the Robotics Club Discord this time, so hopefully more than a couple of folks will join to watch me do this. And I hope to actually, have my act together a bit better this time. Yeah, I got the robot here. Yeah, I had to adjust my camera setup too because I'm doing something different, right? My camera keeps falling over a little here. A Nat Geo webinar. Oh, that sounds fun. I love science and stuff like that. I've been getting into like more space science, like orbital mechanics. Hmm. All right, well, it's 7 o'clock, and for all my viewers, I hope you're having a great night. I'm Josh Booth, and I'm gonna go and program this robot that I've been showing on the screen. So last time I built this robot, and then I tried to program it, and then realized that I kind of don't really know the theory of this thing that well. So what I'm gonna do is I did some research. I figured out exactly how this thing is designed, and I'm gonna tell you guys how this thing works. So let me go over to my web page here. So the thing is, this robot runs off of this L 20, 298N motor controller, basically. Motor driver. It's not a particularly smart piece of hardware, but it's really good because it amplifies things. So that puny little signal coming off of the Arduino gets amplified so that you can, so it actually can drive a motor. The Arduino by itself is not powerful enough to run these motors. So it's this L298N motor controller internally is set up like this. It's called an H bridge, and the idea is like you've got some power, and you can adjust the way that power flows based on which switches you open and close. These are some nice diagrams here. So your voltage is going in the direction of the arrow, and if you close these two switches, the motor will go one way, and if you close these two other switches and open the other ones, it'll flow the other way, and that gets you to rotate the motor one way or the other way. I think another advantage of this, okay, so this has a bunch of pins to it, And let me show you this thing on the actual robot itself. So let's switch over to this robot view. And took a few things off this. I took the, there was a little motor, well, not a servo and a radar, well, not a radar, it's a sonar rangefinder here that were kind of blocking the view, so I took them off. And I took out most of these screws ahead of time. So let me get this off the rest of the way. And this is the motor controller. Now the one that they provided actually is a little fancier. It's got some nice plugs in it for everything, and it's really nice. You know, but right here is that L298N chip, and all these little. You know, of course, I don't want to touch these wires with my piece of metal here. I don't want to short something out, but those are where all the connections to that chip are. This is a nice heat sink because, of course, it makes a bunch of heat, and you know, a variety of other things. But that's the bulk of it. And on this board, it's nice. They have everything nicely labeled, so you can see. I think I'm vibrating a little too much, but it's there's a power input to this board. That's this here. This 6-pin connector with the black wires coming out of it is all of the control wires. That's just your low voltage coming from your Arduino, and then the 4 connectors on the sides go directly to the 4 motors. So let's draw back here, and I'll put this thing back together a little bit. Now, you may think that there's some kind of, you know, complex connection between this this little board and the Arduino, but there really is not. And it actually even tells you that this is basically directly connected to the to these pins. And I mean, it's, you know, well, not quite directly connected. I mean, nothing's, you know, perfect, right? But it's as direct as it's going to get. So you see that same set of 6 black wires. Those come up to right here. And it's got pin listings right there. So it's starting at 6, 11, 9, 8, 7, and 5. So those are the pins that we're actually using directly from the Arduino to connect to the motor controller, to this chip. And those pins, of course, are right here. So what did I say those for? So yeah, so we see pins 6, 6, 5, you know, 7, 8, 9, blah, 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 blah. So you see, and this bottom board is your Arduino. So let's get back to a little bit more theory and we'll program this thing up. All right. So we have that chip that I showed you. I've got a nice copy of it. Of course, there's a couple different formats you can use, but of course we're using, we were provided with this top format. And it's actually 2 controllers in one to control each side separately. So you've got, this is the actual schematic, and then there's a kind of truth table. Now in electronics, this is very common to say, well, what happens when you put a certain amount of voltages into certain circuits? Well, this will tell you what happens. So if you, so if you drive, in this case, it's only like 2 pins, and because the switches are closed symmetrically. But the idea is that you can, if you put 1 pin high and the other pin low, then it goes forward. If you put one pin low, like say, let's see, these, yeah, the C pin low and the other pin high. And by low and high, I mean like powered and, or low would be unpowered, high would be powered. Low would be, so if you switch, it'd be reversed. And if you want to do like a braked stop, like you want the motors to stop as if they had brakes on them, you would drive both of them. So you'd apply power to both pins. If you want to just like freewheel it, you just want no power, you don't want it braked, you just want it to just like coast, you would remove power from both control pins. And that's how you get that thing to work. So these are all the ratings. I've just looked up this website. This is a terrible website. It's full of ads. But you can see this is very similar board to the one that I have on this robot. And except mine has, see there's these motor terminals. Mine's designed to drive 4 motors off of this thing, 2 per side. So mine has 2 2 of these connectors on the left and on the right. All right, so then that's, I think, just, and this is how you would connect it, which is pretty much how I've got it connected, but of course I've got 2 motors per side. So I think that's about enough of theory. Oh, right, and the issue of speed control. So the thing is, it only cares about whether the input signal is on or off. So you may be wondering to yourself, how would you control the speed? Well, because you can't control the speed with the voltage or the amperage or something like that, it's actually controlled by pulses. So if you want it at full power, you just give it like 1 long pulse as long as you want the motors to spin. But if you want it at half power, you actually switch back and forth between on and off, on and off, on and off, on and off. And the Arduino actually knows how to do this. So the actual output signal is going to say on, off, on, off, on, off, on, off. Very interesting. So let's get to programming this thing. So that's what I'm going to do now. Now, of course, we're leaving the world of electronics and entering the world of programming. So in programming for an Arduino, look, you don't have to do it precisely this way, but this is how the Arduino Programming Studio wants you to do it. There's a setup section of code and a loop section of code. And the idea is you're going to put all your setup stuff, that's your label for this section of code. Your setup stuff goes here, and your loop stuff goes here. Well, okay, sorry. I should explain the loop stuff. The loop section, basically, once you've set up your code, set up everything correctly, then it passes control to this loop section. So it does stuff, and then when it's done doing stuff, it starts back at the start of the loop. And it runs this until you cut the power to the Arduino. The idea here is you just are always going to be doing things, right? Your robot is going to be responding to inputs or driving motors or something like that. And you're going to want to put that code right here. And that's, so that's the purpose of this. So let's do some code. Now, if you've really never seen any of this stuff before, you can pretty much ignore the void stuff. That's probably not really relevant. You can also ignore these little parentheses. That doesn't really matter right now either. Anything that starts with this // is just a comment. It's just for humans, by humans and for humans, not for the computer. This does not mean anything. So you can leave it here, you can remove it. It will not change your program. And this // just affects that line. And then this curly brace says that this is a section of code. So this is the section called setup, and this is the section called loop. Not too complicated, but we'll get to some stuff. So you didn't come here to see me talk about theory, so let's write some code. All right, let's do this. So the idea here is that we've got we've got some things that we need to do. We've also got an ability to put some code ahead of time. One thing about this language, there's also you can kind of rename things or say, define some things as something else. So I'm going to define a few things. I'm going to say, and the way you define things in this language is you do # define, and then I'm going to say there's a pin called enable A, Yeah, let me do this. Let me make it all enable underscore A, and I'm going to say that's 5. So pin 5 is going to be going to enable one side of the robot. We're going to define enable B. That's going to enable the other side of the robot to drive. We're also going to define, let's see, there's a input 1, and that's pin 7. Define input 2, and that's pin 8. Input 3 is pin 9, and input 4 is pin 11. So the idea here is that those 6 wires that lead from the Arduino directly to the that chip. These are the pins that are used to communicate along those 6 wires. You have 2 that enable either the left or right side. I forget exactly which one's which. And then you have 4 pins that define the direction that your motors are driving in. These are just going that way. And the reason I did this is because I don't know what 5 means. I'm going to look at this code and then like a month later be like, what the heck does this stuff mean? And by putting these define enable A in there, I'll be able to figure out pretty quickly what I was doing here. So now I'm going to set up our pins because they're not actually set up. I did this more for convenience, but then I'm going to use a command called pin mode to go and say how these pins are going to work. These all have to be configured on the Arduino as an output pins for obvious reasons. They provide output to something else. So in this case, I'm going to say for enable A, it's going to be an output pin. And every line, I got to finish it with this semicolon, and it represents the end of a statement. And if I don't put it there, the program gets mad at me. So I'm going to do that. So then I've got, I can just copy it. I'm going to make this quick. I'm going to copy this, paste it down 6 times, and just copy and paste because I need to make all of these output pins. So I'm going to do that now. All right, so now all of my pins have been defined as outputs, and I'm saving my file now too. Okay, next step, I need to let's drive some motors. I mean, what else? That's what we're here for. So let's do something fun. Let's say we saw that we needed to set up these drive these different pins in a certain way. So we need to enable one side. So let's enable the A side. And in order to do that, I'm going to output a signal. And to do that, I need to do digital write. And just basically says, give me full power on this pin, on a digital pin. So the pin is enable A, and I'm going to make it high. And then in order to tell it what direction to go in, I got to also say, I got to drive the direction pins, right? So I'm going to say that digital write to the input 1 pin, make that also high. And now these have to be opposite, right? So if if input 1 is high, the input 2 has to be low. And I think this should work, right? I'm really just going to drive one side at the moment because I think that's all that's going to really matter here. And yeah, so let's try this. Now, there's some things you can do here. There's a check here that can verify my code. It says compiling sketch. And all right, it's compiled and it should work. Well, it should do something. I don't know whether it'll work. But the idea is then I need to send it to my Arduino. So in order to do that, I've already plugged it in. I should also verify some settings. Yes, I'm using Arduino Uno. In my case, it's on COM8. It's a communications port, and this should be the correct programmer here. So let's try it. And you gotta just hit this upload button. All right, and did it work? Let's take a look. All right, let me unplug it, turn it on, and look at that. The wheels are just running uncontrollably at full power. That's pretty much exactly what I programmed it to do. Let's shut it off now. So that's the basics of how you get this thing to work. Now, of course, we can drive the other side. So let's switch back here, and we can now do the similar thing. Are we going to call that the right side? We're going to call that the left side. Okay. So I think that's the left side. So I guess enable A and pins 1 and 2 represent the left side. So maybe I actually want to change. Yeah, I'll leave it. Yeah, actually, you know what? I do want to change it. I'm going to say enable. I'm going to rename enable A. I'm going to do this. Enable A. I'm going to change it to enable left. And replace all. There we go. And input 1 will become, let's see, which way was that going? You know what, I forget which way it was going, so I don't want to change that. But let me also change enable B and to enable right. And that should help me remember which side is running in which way. So let's see, then we have this, and I'll copy and paste my code and change the pins here. So now instead of the left side, I'm going to say enable right. Use inputs 3 and 4. All right. Plug in my Arduino again. Upload it. Okay. Turn it on. Okay, yeah, I think this makes, so it's making, the way I got to set it up now, it's making the left side go forward and the right side go backwards. So this would really just spin if I put it down on the ground. So let's shut it off again. So we've learned quite a bit here. So now we can update our code a bit. Maybe we can actually get them going in the same direction. So let's swap our direction pins, low and high. Yeah, let's see, what else should we do here? I think we should, so then if I upload this, this would allow us to drive them in the same direction, which is great. But then that's kind of too much for me to show you how this thing driving on my desk. So I'm going to reduce the power. Now, one interesting thing about these pins, you know, I told you that it uses pulse width modulation, or like, you know, quickly switching the pins on and off in order to control the power. Well, the way you do that is you can, well, there's only certain pins that allow you to do that. And basically you see this little label on the side here, PWM. It tells you, it says anything with this tilde or this squiggle is a PWM pin. So of course our enable pins, the enable left and enable right pins are 5 and 6, and you can see both of them have those squiggles on them. So that means that we should be able to drive them using PWM. Now it's actually a different command, so I'm going to show you a different command. Instead of digital write, I'm going to use analog write. Now you may have noticed that these are digital pins, so how do you do an analog write to a digital pin? Well, the idea is that it's actually going to do that pulse width modulation for you based on the number that you provide to it. And that number I think is from what, 0 to 255. So I'm going to give it a number of, like, let's say 100 on both of these pins. And that should reduce the speed of the motors. So let's try it. Okay, done uploading. And yeah, I think that's going a bit slower than before. I don't think that's quite slow enough to work on my desk yet, so let me make it slower. I'm going to say 50. Okay, and let's try that. Oh wow, it's not even enough power to make it go. That's definitely too slow. Let's try 80. Okay, hit program. Okay, turn on the power. Well, let's unplug it. Barely enough. But it works. How about that? So that's how you drive these motors. Now, you can do some other things to make this a little bit more convenient. Yeah, I don't think 10 is going to quite work. I think 80 is probably close to the bare minimum. So let's do, let's see. So now we've got our motors going. And let's break up this code a little bit into something that's a little more manageable. So we know how to go forward and back and left and right. So what we can do, at least, is separate these things into, well, let's see. Do we want to start separating this out now? Yeah, let's do that. So maybe we want to make, so you see these, this group of code, this is a function, and you can actually call functions from other functions. So let's make some functions. So I'm going to do that. I'm going to create a function that will go forward, a function that will go backwards, one that will go left, and one that will go right. So my forward function is going to be just like my loop function. In fact, I can just copy the loop, paste it here, and then rename it to be forward. I obviously can't call it loop. Well, I mean, it's not obvious exactly, but everything needs a unique name here. So that I'm going to call it forward. And in fact, I'm going to take all this code here, and I'm going to comment it out just to show you how much space I'm saving by separating it out. So instead of calling these 6 lines of code, I just do forward. And that will accomplish the exact same thing. And to prove that, let me show you by uploading this program. And there we go. It does the exact same thing. There we go. Yeah, I think 80's not quite enough either. let's make that maybe 100. I think 100 is probably just about enough, just barely enough to make these motors start. Now you may be wondering to yourself, why not? Why doesn't 50 work? Or why does 80 barely work? Well, you know what? It turns out that motors have internal friction, and you can't just expect it to work with a tiny amount of power. Real world gets in the way of programmers' designs. So let's get rid of this extraneous code here, and let's make another function here. Maybe we'll call it. I'm going to do a right. I'm going to make it turn right. So this is, we want to enable, and in my operation to turn right, I'm going to enable both sides, but I got to drive the right side backwards, I think. So I'm going to swap low for high and high for low. Now, this is not really useful right now because this loop just runs continuously. It's just going to say go forward, go right. Or it's just going to say go forward. And if I put right here, it's going to be very confused because it's going to try and go forward and go right and go forward and right and forward and right over and over and over again, more faster than you can think, really. So it's, I mean, I could show you. It's not going to work. It's not going to do what you might expect it to do. So let's try that. So one side's moving, one side's not doing anything. I think it's just fighting with itself. So we're going to put in some delays. So maybe I actually want to go forward for like a second and then turn right for a second. And I can do that. I can use a function called delay. And that delay function will just keep it doing whatever it's doing, but just wait. So let's do that. Delay, and this is in milliseconds. So I'm going to delay for 100 or 1,000 milliseconds, which is 1 second. And then after that, after I tell it to go right, I'm also going to delay. So it's going to go forward, wait for 1,000 milliseconds while it's still going forward, turn right, then delay for another 1,000 milliseconds or 1 second, and then go back to the start. So let's try that. Oops, I wasn't showing you my code. Yeah, so it's going to go forward, it's going to delay for 1,000 milliseconds, go right, and go and delay for another 1,000 milliseconds. Let's program it. And let's take a look at the robot. Power on. And look at the right wheels. Forward, back, forward, back, forward, back. So and the whole time, the left side is going forward. Let's see if I can do that on my desk here. Yeah, so forward, turns right, forward, forward, turns right, forward. Now, if you're really going to do this for real, you probably want to tweak it around one way or the other. This is where testing and programming comes in. And you might want to actually, give it a little more thought to exactly how you want it to work in order to make it, work properly. But that's the general idea. And you can continue breaking out these methods. So of course, I've got a forward and I've got a right. You can copy these and reverse them and make backward and left. And then you've got all kinds of crazy stuff you can do. So let's see. So that's some fun stuff. What else can we do now? I'm thinking maybe I gotta have some external control. Let's do something like that. There's also an infrared sensor on here. There's a way you can use a little remote that will send information to your robot. Right now, it will do nothing because, of course, I did not program the robot to listen to the remote right now. But what I can do is start to do that. So I'm going to start writing some code. Now, of course, the way this works is basically I've got a little, how do I show this? This little, no, wait, where am I? This little guy's your infrared sensor, and it will listen to the infrared signal being put out from this thing, this little remote, and it will be connected to pin number 12, and that pin will go and receive the signal, and which can be interpreted by your code. So we're going to receive the signal and write up the code to interpret it. Now, I'm not actually going to write up the code myself because, come on, that's actually a lot of work. There's a certain encoding for this thing, and it's actually kind of involved. So what I'm going to do is I'm going to cheat. And in programming, cheating is actually encouraged because, honestly, there's a lot of stuff that's difficult to do if you don't have the right resources. So there's a library called IR Remote, and I'm just going to pull that in. So what I did was I go to Sketch, include library, and I found the IR Remote library of stuff. You think of it like, you don't know something, so you go to the library to look it up. And so it's a library of methods, and it's going to let me do things. Should be interesting. In this case, it's going to let me receive that signal from the infrared remote. So what I'm going to do here is I'm going to take the take my start to define. Okay, well, which pin it? And you saw it was pin 12, and so I'm going to define that. I'm going to say there's define receive. People like to shorten receive as rec_v. Pin, and I'm going to say it's 12. And then, so now also I need to have a place to put that result, or the signal I'm getting from the LED, or from the LED remote. I'm going to call that. There's a something called decode results, and I'm going to say results. So what I've actually done here is something I haven't done yet, which is define a variable. In a program, a variable is something that changes, and you can define it. Now, someone in this library defined a variable called decode results. And I'm not going to pretend to know what's in it. I know that there's a value in there, and other than that, it's magic. I don't really want to know, and I don't really need to know. All I need to know is that it's going to give me what I want. So I'm creating a variable called results, and the type is decode results. That's what we're going to put in there. So in order to let's see, and then there's also we need to start telling the library that, hey, we'd actually like you to listen for infrared signals. So we got to type out this line. IR rec_v, IR rec_v, and tell it we want to use this pin. And don't ask me to explain this right now. I forget exactly how this works. But basically, this line is going to tell that library, hey, we want you to listen for infrared signals. And you can just consider it magic at this point. So we're going to, what we're going to do is go to our setup method here, setup function, and tell it, okay, we're ready to receive things. So that's irrecv.enable ir in. So that's going to say, hey, we're ready to start receiving information. And you know what? At the same time, let's go and set up our serial port. So this, this Arduino robot has a USB connection to the computer. Well, it turns out USB can act just like a pipe of information. And so what you can do is you can send information back along that pipe. This is what I'm doing here. I'm saying serial.begin 9600. And that's going to let me start sending information back to the computer from the Arduino. And I'll be able to see it using a special tool here. And let's see what else. I'm trying to. I think I've lost a command. I'm trying to remember this other command that I need to use. Sorry about that. Let's try something. All right. Yes. Okay. So the number more. Let's see. A couple more commands. I'm going to, in this loop, I don't want it to drive forward or right just yet, so I'm going to comment this out. Instead, I'm going to use what the library tells me to do. It says that I need to put this code here. I need to, there. And you can just not really worry about what it means right now, because it just does stuff. In fact, and I'll show you what it's going to do. So I'm going to upload it. Oh, I forgot to define a variable. That's right. Right, let me create another variable. Oh, you know what? I'm going to change this. I'm going to not get rid of that. All right, more magic. See, code doesn't work all the time. All right, it's programmed. So let's, let me switch back to my little camera of the robot, and you should see when I turn it on, it's going to do, let's see, I forget, is it on or off? There we go, yeah, it's on. It's doing nothing. And that makes sense because I have told it not to do anything. Now, you'll see that when I hit the IR remote, there's a little light that blinks, but that's about it. That's not where the fun part is. The fun part is back on the computer, where I can go to Tools and open the serial monitor. And this lets me see what the Arduino is telling me. And what it's telling me is that every time I hit a button, there's a number that represents the exact button that you're pressing. So I'm pressing, say, the up button. And there's two numbers that are printed out. Let me clear it to make it more clear. Up button. And I got the number 167366925. You're probably thinking, what the heck does that mean? Well, I don't know either, but that represents that up button. Hit left, and that's, I don't know what the 255 was, but 167200605. So that's left, that's right, that's back. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, star, 0, and pound. So we know what these buttons correspond to now because we saw them in this output. So we can start thinking, what do I do with these with this input? Why don't I, every time you hit a button, what if I just tell it to drive forward? I'll do that. So let's see, which button do we like? I guess we should probably use the forward button to drive forward. Who would have thought? So that would be this number. 167, and you're probably wondering what's this number. Well, we'll get to that. This is the forward number. So let's take that and say if results.value equals that forward number, then let's go forward for forward. Let's then delay for, let's do 2/5 of a minute. Let's see, a quarter of a second. Let's do 250 milliseconds. And then I would like a stop method or way to stop. So I'm going to copy forward and then make it a way to stop. So I'm going to say I want it to output 0 on the left and right sides, and I want it to be a break stop. So I'm going to write out high, everything is high. And it's not forward, I want it to break. So go forward for a quarter second, and then break. And then wait for the next command. So let's try that. Let's go and program it. Power it on. And let's try it. And I guess it doesn't work. Whoops. Yeah, I think what I did, I think I did this wrong. And I think that's where we need to get into the details of how this thing is supposed to work. So what I'm going to do is I'm going to put a variable here. I know I haven't explained this library yet, but I'm going to put a variable here that will be an unsigned long, and I'm going to call it value. So that when we get the value from here, let's go and put it in the value variable. And let's use that variable value instead. I hope this works. Okay. Oh, and it still does not work. What's my serial monitor saying? I thought this would work. Well, I guess not everything can work, can it? Oh well. But that's how you receive signals from your infrared remote. Let's see. Maybe I can find a version of this code that actually works properly. Let's see. Instead of me just goofing around on a live stream trying to figure out how to program this thing properly. So I've actually got all the code from the Elegoo website, and they just gave it to me. It's no big deal. Wow, yeah, that's a lot of stuff. So, but the idea here is, yeah, I thought that was the way it was supposed to work. Anyway, Yeah, so I'm going to, let me just use that code. Upload that one instead. Of course, I didn't switch back to my code view here. So I'm using this this sketch, this set of code instead. Oh, well, access denied. It must be because I've got that serial port open. There we go. Let's try it again. All right, uploading, done uploading. So let's see if this works. There we go. You know what? I wonder if my code actually did work. Maybe I just didn't have the thing programmed or turned on correctly. Let me try that as well. So this is the code that I was using. Let's go and try that. Okay, done uploading. Yeah, I think maybe that's the problem, is that I thought it was on perhaps, and sometimes it's hard to remember whether I've got this on or not. Okay, here's my original code. There we go, see? Every time I press that button, it just moves forward just a little bit. How about that? All right, I'm happy with that. Now, of course, what you can do is go and start taking this code and start improving on it. Of course, before you start improving on it, you should probably understand what this infrared library does. So basically, in your loop, it's, like I said, this infrared library is always listening for signals. And when it's ready to give you a signal, it won't really tell you. You got to ask it. So this is where the ask part is here. This if statement. So you got to ask politely, irrecv.decode and ampersand results. And basically it's saying, if you got something, decode it and put it in this results variable. And also return a true or a false if you got something. So if it's if it's true, you'll run this. You're going to run the rest of this code. If it's false, it means that there's nothing there, and just keep on going. Let it loop for a bit more time. So what I added was this serial.println, and that's going to take the value that was received and send it back to your computer, because it was fun to see what that value was. I also decided I'm going to put it in a value variable. So I'm going to say the value is equal to results.value. And then the library says you also have to say irrecv.resume, because it's going to decode once and then stop trying to listen for more signals unless you tell it to resume. And then here I check, well, okay, what's the value? In this case, I say, well, if the value is equal to that forward value, run the forward function, delay for 250 milliseconds, and then stop. And that's all I did. So obviously, you can take this and start to elaborate on it. Of course, this only goes forward for a very short period of time, which is not really very useful. But what you could do is start adding, the ability to turn left and to turn right, or go backwards, or things like that, or shoot cannons, or whatever you program this Arduino to do. So that's really just up to you. So I think that's all I got. I'm just happy that I was able to get this thing to work. So this is a fun little piece of machinery. So I hope you guys come back and you can see me doing other things with this little robot. So until then, have a great night.